this video for Computer Science 9618 A-Level, we're going to take a look at another paper for a walkthrough. This one's going to focus on the May-June 2024 exam, bit variant 2. So we just did variant 1 a little while ago, so this one is variant 2. So let's go ahead and jump into question 1. 3 source files are used to answer question 1, so we're going to be using that reading from a file right here in this very first question. A program outputs a main word. The program asks the user to enter the different words of 3 or more letters that can be made from the letters in the main word, and these are called the answers. Now, there are 3 files: easy, medium, and hard. Each of those are going to be a text file. Each file has the main word on the first line. For example, the main word in easy.txt is house. The answers are stored in the file. Each answer is on a new line after the main word. So we know all the answers, all the words we can make from the word house that are 3 or more letters are going to come after line 1. So it says, for example, easy.txt has 14 answers that can be made from the letters in house. The words read from the text file are stored in the global array word array. So right there, I know I'm making a global array called word array. They give us that name, so that's what they want us to use. The number of words that can be made from the letters in the main word is stored in the global variable number of words. Then it says the procedure read words. So I know it's a procedure, not a function, so it's not going to return anything. It takes a file name as a parameter. So when you're taking this test, right here, this can be a little misleading because usually when they have the procedure or function with the name of it, read words, usually they're going to put that parameter inside the parentheses. Sometimes they don't, and that's because that's going to be a point that we can earn. So it takes a file name as parameter. Well, there's only 3, easy, medium, and hard, each of those being .txt. Opens the file and reads in the data, stores the main word in the first element in word array, stores each answer in a new element in word array, counts and stores the number of answers, write program code for the procedure, read words, nothing that we can't handle. So let's switch over to VB and let's pick up the first 6 marks of this exam. Okay, so the first thing we're going to do is we're going to import that system.io so we can have a stream reader. We've got to be able to read the file. And then they wanted us to create a couple global variables. The first one was word or number words. And that's an integer. That's easy. That's not an array. Now the array they want us to do, which is the word array, that one's a little more tricky because we have to know the size. So I opened up easy, medium, and the hard.txt. I went through. I know there are 97 words. So I'm going to do that as a string. So now that we have those, we can go ahead and create that procedure, which means it's a sub. The sub name was read words. It does take a parameter. That is the file name as string. So I'm going to use a file. Now I do need a file handle able to read that file. So I'm going to do that as a stream reader. And that's why we import the system.io so we can get this. Now, anytime you're trying to read a TXT file or open a file, you always want to do that inside a try catch statement. Let's go ahead and handle that catch. Console.writeLine file is not found. Because if we try to open the file, we don't want our program to crash. We want to catch that statement or catch that error and simply output a suitable message, file is not found. So inside my try statement, I'm going to do file handle equals new system.io.stream reader. And what is the file I'm trying to open? Well, that's simply going to be file, and that's the easy, medium, or hard that's going to be passed down. Now, I want to do until we get to the end of the file, and I do that with end of stream. Now I need to read each line, take the data in that line, store it in my word array. So I'm going to do my word array, number words, and that's going to be file handle dot read line. We already have the end of stream that we actually want to read the line now. Then I need to increment my number of words. So we move on to the next one. And the very first index is going to be the main word. So inside index 0 is going to be the main word. And then I move on to the next index by doing or incrementing number of words. And we'll read all the way through. Don't forget, you always want to close your file, and you want to do this outside the loop. If you do it inside the loop, you're going to read one word and then it's going to crash. So we don't want it to crash. We want to close the file at the end. And here it actually, yeah, it would crash because inside the loop, we're trying to read the line, but if we close it inside the loop, it's going to read one word, and then it's going to say you can't read the line because it is closed. So we want to do that outside the loop. And just like that, we are done with the first part of the question. We picked up 6 marks. Let's go ahead and move on to the next part of the question. The main program asks the user to enter easy, medium, or hard and calls read words with the file name that matches the user's input. For example, if the user enters easy, the parameter is easy.txt. Now, what you want to watch out here are for these lowercase and uppercase easies. There's a couple different ways you can do it. You can use if statements, select case statements, or you could actually use string manipulation that takes this word and uppercases the first one. We're simply going to use if statements to handle all of that. Now, it doesn't say to handle anything that doesn't work, so they're going to enter just easy, medium, or hard. We don't have to do any error correction or anything like that to handle if they enter something else besides that. So let's swing over to VB and let's pick up these 4 marks to bring our total to 10 marks. So the main program simply means sub main. So that's where we're going to do this. The first thing we're going to do is choice as string, because we're going to ask them easy, medium, or hard. Which one do you want? And then we need the file name. That's going to be a string as well, because if they choose easy, then we got to make the file name easy.txt and pass that down to that procedure we just made. So we're simply going to do a console.writeLine. Do you want easy, medium, or hard? Now, what we're going to do is we're going to do choice equals console.readLine. Then what we're going to do is we're going to do choice equals choice dot to lower, make it all lowercase. That way we don't have to do anything. If we're going to do choice dot to lower, we need to store it back in choice. This will lower everything in that string, and now that makes our code a lot easier to work with, just in case Cambridge wants to see it. If choice equals easy, then our file name equals easy.txt. Make sure you put that capital E in there. Then we're simply going to do an else if, and else if choice equals medium. Then what we want to do is we want to change that file name equal to medium.txt. And then if they, our alternative is the file name, because if they enter hard, it's going to be hard.txt. Now, usually, sometimes on the exam, it'll say output an appropriate message if it's not a valid input. In this case, it did not. So they're only going to enter easy, medium, or hard. Once we do that, all we have to do is simply call read words and pass that file down. So we're going to do that outside our if statement, read words, and we're going to pass down file name. And we want to spell that correctly. And just like that, we're done with submain. We picked up another 4 marks. Let's take a look at the next part of the question. The procedure play outputs the main word from the array, so we know that's going to be the very first index. So mine's being held in index 0, and the number of answers. That's going to be held by number words. Allows the user to enter words until they enter the word no to indicate they want to stop. So we're going to need a loop here that's going to keep going until they enter no. Outputs whether each word the user enters is an answer or not an answer. Counts the number of answers the user gets correct. Replaces each answer that the user gets correct with a null value in the array. And that will prevent them from using the same word more than once to earn an infinite amount of points or to make sure they always win. Write program code for the procedure play. So let's swing over to VB and let's go ahead and code this out. Okay, so we have 3 variables that I think we're going to need. Response as string, that's going to hold what the user types in, including no if they don't want to keep playing. Success, we need to know did they guess correctly? Because we got to output a suitable message, and then we need to output how many they got correct. So the first thing I'm going to do is output that main word. So we're going to say the main word is, and we know that's going to be in our word array inside index 0. And then we need to let them know how many words can be found. The amount of words to find is, and that's going to be number words. And we can see, because it's a global array, we know what it's going to be. Actually, I'm looking at this plus equals 1 here. It's actually going to be number of words minus 1. And the reason for that is because we increment. So let's say there are 15 words in total. When we're on word 14, we're going to store inside word array 14 file handle.readline, then number of words plus equals 1, which goes to 15. We store the 15th word, and let's say that is the last one. This gets incremented to 16. There is no 16th word, because when we loop back around, we would exit. So it's actually going to be number words minus 1. So I don't think Cambridge will mind if you go more than that, because we got a lot of indices in the array. So I'm actually going to make that array 100 here. There we go. I'm going to make that 100, and that because we're going to be using number words to control everything. So having just a little bit more room than we think we need will make sure our program doesn't go outside the bounds of the array. We don't want to find an error later on as we get closer to the end of this question. Now we need to keep looping until their response is no. Now I don't think that's ever going to run, because I'm thinking about what they're going to type in. So let's give them a prompt. Enter a word or the word no to stop playing. We'll say stop playing. And then our response equals console.readline. Now, if their response equals no, then we're going to exit the do loop. There is no point in traversing through the entire array if they're done playing. So we're just going to exit the do loop, and we'll let them know how many points they got. Show them the points. I'm sure Cambridge is going to have us do something a little later. If not, we'll output the points at the end. Otherwise, there's no point in keeping track of the points. Now, we're going to do for I equals 1. 0 is going to be the main word. They can't use that as a valid selection. 2, number of words minus 1. So if I go to index 5, if that's my last word, number of words will actually be set to 6. I don't need to check that extra one. Could you go to number of words? Sure, you can. Not a problem. I don't think Cambridge is going to fault you for that, but we want to show them that we know what we're doing. Now, we need to see if the response is equal to that index of our word array. If it's equal, then we know they have gotten it correct. Now, actually, before we enter this for loop, we need to set success equal to false, because they haven't found the word. If we leave it as true, it's always going to say they found the word. So we want to reset success back to false. We need to replace that word array index with a null value. We're going to increment how many they got correct. And then let's see here. I think that's all we need to do. Now, outside, you know what we can do? Once they find the word, we don't need to stay inside this loop. We're going to exit that for loop, go right outside this next before it loops back around. And what we're going to do here is we're going to do an if statement. If success equals true, then what we're going to do is we're going to let them know your guess is correct. And then we're going to let them know their score. That brings your score to, and then we're just going to output how many they've gotten correct. And then we're just going to use an else statement, because if success isn't true, then it's false. and we'll just say, sorry, that is incorrect. Now they don't lose any points, and then it'll loop back around. If they hit no, we're going to jump right down here. So I think that's everything we need. Yep, and if you're getting worried about that number of words -1, you can take it out. I don't think it's going to mind. Later on, I think it's going to, be a big deal. But right now, I think we can be just fine with it because we know how to count how many words there are, not including the main word, because the main word is not a guess. All right, so that's going to wrap it up for that part. Let's move on to the next part of the question. Amend the procedure play so that when the user enters the command to stop, the procedure outputs the percentage of answers the user entered from the array. So let them know what percentage they got correct. Outputs all the answers that the user did not enter. Write program code to amend play. So we just need to update it. And we need to let them know what percentage they got correct and what words they didn't use at all that were in the array. So that's why they had it set to a null value. So that's why they had us do that. And here, number of words -1 is going to come into play here. It's going to come into play to make sure we get the right percentage. So let's swing back to the program and let's update play to handle that. So we're going to need to calculate that percentage. So what we're going to do is we're going to do not diagnostics, but dim found as decimal. One of these days I'll be able to spell correctly on the first try. So what we're going to do is we're going to calculate found. So we're going to do found equals, and that is correct, divided by the number of words -1 times 100. That will give us the percentage. Then we're going to let them know how many what percentage they found. So if they get 14 out of 14 words, that's 1 times 100 is 100%. You found, and what we're going to do is we're going to do found, which is the percentage. We're going to put that percentage sign of words. Now, they may not have found all the words. So if found is less than 100, because remember, it's a percent. So if it's less than 100, they missed something. So then what we're going to do is we are going to traverse the array. As long as it's not equal to being empty, we're going to output it. So we're going to do, let's do this, console.writeLine. Actually, let's do that. Well, no, we can give them a title. Console.writeLine, let's give them a title. The following words you missed. All right, so for I equals 1 to number words -1, because we don't need to go beyond. If number words, and we're checking that current index, is not equal to being empty, then we're going to output that word. So we're going to say number words, not with quotes, because we're creating a list for them. Number of words, I. We're going to let them know. Oh, it's not number of words. It's the word array. What's going on here? Word array. So there we go. Number of words is not an array at all. So if it's not equal, get rid of this plus sign, to being empty, then we're going to output it. If it's empty, we're just going to move right along. So that's going to be it for that. And just like that, we picked up a few more points on this paper 4 exam. Let's go ahead and take a look at the next part of the question. The procedure read words calls plays or play after the data in the file has been read. Write program code to amend read words. 1 line of code for 1 point. We can easily do that. Let's switch over and do that. So read words calls play. So we call it by its name, play, no parameter, just like that. We're done with that part of the question. Let's go ahead and move on to the next part of the question. Now they want us to test our program by inputting the following words in the order shown. Easy. So we're going to run that easy.txt file using sheouts and then nodes in the program. Then run it again, this time using hard mode, find idea, and then no to exit. So they want us to take a screenshot of the outputs. So let's swing over to VB. Let's run this and make sure we get exactly what we're supposed to get. Okay, so the first output they wanted was easy. The main word is house. The amount of words to find is 14. That is correct because I just went through the easy file and I counted the words. There are 14 words. So that is correct. So if you're off by one and you're taking this exam, because that's something that I almost missed, just make sure you're looking and, use some time to actually count those words. All right, enter a word. So the first word they want us to enter is she, and that is correct. Out, we can't make with the word house, so we should see that is incorrect. Okay, then no, and we should see our percentage. Ooh, negative 93.3%. That is not right at all. So let's take a look at that math. Let's fix that math right now. Let's see here. So found is a decimal. Oh, because it's subtracting 1 at the end. So what we want to do is we want to follow those order of operations. Number of words minus 1. We want that to run first. So we should get 7 point something. Looks like around 7.67. So let's run it again. Now that we have the right math, we want easy. Okay, so we want to type in she, which is correct, out, which isn't, no to stop playing. That is, that looks more correct. Yeah, we don't want to say we got negative 93% of the words. That's not even possible. All right, so we have our calculation here. The following words we missed. Now, there should be 13 words here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there are 13 words we missed out of the 14 because we only got one. Now what we need to do is run hard and make sure that works as well. All right, hard mode, the main word is fainted. They want us to enter find. Now that should be a word that we can build. Perfect. Find is another word. Okay, then idea, and idea should be one that works as well. All right, so we got 3 of right around 100 words. That should come out to around 3% something. Oh man, look at all these words we missed. There are a ton of words in that file. And yep, we got right here 3.09 with a bunch of numbers. That's what percentage of words that we found. So we also outputting the score, but look at all those words we missed. I have no idea why Cambridge made the file that big, but they did. But that's okay. That wraps up question 1. Let's get ready to move on to the next question in the paper 4 exam. A binary tree stores data in ascending order. For example, I was wondering when we were going to see a binary tree question, and now we have. I've seen a couple other ones, but to throw it with object-oriented programming, that's amazing. It's also, I think, going to make it a lot easier to code out. We'll see in a minute. So you have to have a basic understanding of how binary trees work. 15. I know that was the first number entered because that's our root node. I don't know what number was entered next. It was either 8 or 19. Let's say they enter 19. They check it with the root node. 19 is greater than 15, so it goes to the right-hand side. Then they enter 8. 8 is less than 15, so it goes to the left-hand side. Then they enter, say, 3. 3 is less than 15, so we go to the left-hand side. Something's already there. 3 is less than 8, so it goes to the left-hand side of 8. Then they enter 10. 10 is less than 15, so it goes to the left-hand side. There's already something there. 10 is greater than 8, so it goes to the right-hand side because that is free. It is open. A computer program stores integers in a binary tree in ascending order. That's extremely important. We know we need to handle the left side of the tree when we're outputting, followed by the right-hand side of the tree. Now, if you watch my binary tree video, you'll know that we used a recursive sub to do that. We'll see how they want us to output it here. The program uses object-oriented programming. Nothing we can handle here. The binary tree is stored as a 1D array of nodes. Each node contains a left pointer, a data value, and a right pointer. So all these nodes have that. The class node stores the data about a node. So the class node here isn't actually building the tree, it's just building the nodes. So a computer program stores integers in a binary tree in ascending order. We said that. The class node stores data about a node. So we have our attributes or characteristics here. We have the left pointer stores the index of the node to the left in the binary tree, data which stores the data, and then the right pointer stores the index of the node to the right in the binary tree, because remember we have a 1D array of nodes. We have the constructor, we have our get methods, and when we have get methods, we also have set methods. These are going to be tied together. Set methods assign the pointer in the data. Your get methods is going to return that pointer in the data, and then our constructor initializes data to its parameter value. So we're going to have that. And then left pointer and right pointer is going to be -1. We can set that directly in the constructor. That doesn't need to be a parameter. So let's take a look at what they want us to do. Write program code to declare the class node and its constructor. Do not declare the other methods. Use the appropriate constructor for your programming language. So let's swing over to VB. Let's write code to declare the class node, doing all those properties and the constructor, and pick up 4 easy points. So we're going to start that class off with public class. They called it node, so we're going to call it node as well. Now remember, all your attributes need to be private. So we're not going to use the keyword dim. We're going to use that keyword private. We have a left pointer as integer. We also have a right pointer. That's an integer. And we have data that is also an integer. Then it said we need to do the constructor. So it's going to be public sub new. It does accept a parameter. So I'm going to do d as integer. I'm going to set data equal to d. My left pointer, they want us to set equal to -1. The right pointer, we want to set equal to -1 because that's what they told us to do. Now, -1 is a null value. So when a node does not have anything to the left or to its right, it has a null pointer, and they're using -1 as a null pointer here. So we're done with the first part of the question. Let's take a look at the next part of the question. And now it's time to write those get methods. Get left, get right, get data. Each return the relevant attribute. Let's go ahead and write those 3 get methods. Make sure you're inside the class for your get methods. So that's going to be public function, get left. No parameter, it returns an integer value. So we return left pointer. Then we're going to do the same thing for the right pointer. So public function, get right, and that's going to return an integer value. So we return right pointer. Then all we got to do is create a function, a return function or get function for the data. So we're going to do the same thing. Public function, get data. That also returns an integer, and we return the data. And just like that, we have our get methods. Let's take a look at the next part of the question. Now it's time to write those set methods. Set left, set right, set data. Each take a parameter, and that is the standard practice for set methods. Set methods usually or will almost always take a parameter. Get methods hardly ever do at all. But these set methods each take a parameter and then store this in the relevant attribute. So let's go ahead and code out those set methods. So you want to be in your class. I'm going to write mine above your get methods. You can write them wherever you want. They don't have to go above your get methods. You can write them anywhere you want. So these are going to be subs because they're not returning anything. So we need to do set left. Now that accepts a parameter. So I'm going to do L as integer. And then what I'm going to do is I'm going to do left pointer equals L. And just like that, I have my set method. I need to do the same thing for the set right by val, R as integer, because that's my parameter. And then I'm going to do my right pointer equals R. Then I need to do the same thing for the data. Public sub set data by val, D as integer, because those are the parameters coming in, and I set data equal to D. So we have our set methods. Remember, the set methods are going to 99.9% of the time take a parameter. Your get methods will not. Also, your set methods are subs, while your get methods are functions. So why is that the case? Remember, your get methods are returning a value. Your subs are not returning a value. They're simply setting the value. Let's take a look at the next part of the question. The class tree class stores the data about the binary tree. Anytime they're having you create another class within the same question, which is going to be object-oriented programming, you have to ask yourself, are we using inheritance here? And the answer is no. Well, how do you know if you're using inheritance? They will tell you that this class would inherit another. We don't have that here, so this is a separate class. Now, we do have an array called tree of the node data type, so we will be implementing the other class because we have an attribute of nodes here. We also have first node that stores the index, not the value, but the index of the first node in the tree, and then how many total nodes are in the tree. The constructor, every class is going to have a constructor. Now in this one, we're going to initialize the first node to -1. That's what they're using as a null value. So when we create this tree, it doesn't have any nodes yet. So they're setting it to -1 and the number of nodes to 0. Now it says initializes each element in the tree to a node object with a data value of -1. In inheritance, we have to call the constructor in the parent class. We're not doing that here. Yes, we're using the constructor in the node class because we got to pass the data value of -1 to it, but we're not using it in the tree class. We're just making a call to it to set this node attribute data value to -1. We don't have to do the left and right pointers because in the node class, they are already set to -1 by the constructor. So that's why we're not going to pass those values. We have insert node, which takes a node object as a parameter, inserts it in the array, updates the pointer for its parent node, whether it's on the left or the right of its parent. And then the output tree outputs the left pointer, the data, and the right pointer of each node in the tree. And then they have a note here. Nodes cannot be deleted from this tree. Well, what do they want us to do? Write program code to declare the class tree class and its constructor. Do not declare the other methods. All right, so let's swing over to VB. Let's code this out and get ready to start making some objects. When you're creating a second class, make sure you're outside your submain. Make sure you're outside your other class. And it's going to be just like we've done everything else, except for because there's no inheritance, we don't use the word inherits. Public class, tree class, and then we create our attributes as private, just like we've always done. So they have one tree. Now that goes 0 to 19, and that's of the node data type, which we have created here. We also have the first node. That's going to be an integer. We're going to set that to -1. And then we also have the number of nodes, which are just number of nodes. That's an integer as well. The other thing they want us to do is create that constructor. Now, when we create that constructor, it's going to be public sub new, just like it is. And it doesn't take any parameters. So we don't have any parameters here, but we are going to set some things. We're going to set the first node equal to -1 because that's what they're using as a null value. And then we have, how many nodes do we have? We don't have any nodes. Now what we need to do is we need to initialize this array of nodes that we have. So we do that in a for loop. For I equals 0 to 19 because I'm starting at index 0 because when we looked at the question, it said 0:19. So 0 is our lower bound, 19 is our upper bound. If you admit index 0 in a binary tree, and you're not going to use index 0, then you could use 0 as a null pointer. Because we're using index 0, we can't use 0 as a null pointer. We have to use -1. So we're just going to do for I equals 0 to 19. We're going to do tree I, because we need to set each index of that tree to a new node. Now remember, you'll see we have a red line here, and that's because it accepts one parameter. So when I type in -1, because that's what we're setting it to, we're good to go. So we have our next in sub in class. We are good to go, and our public class tree class, it's set up, ready to go. Let's take a look at the next part of the question. The method insert node takes a node object, new node, as a parameter and inserts it into the array tree. There's nothing to be intimidated by here. You're going to pass this node object just like you would any other data type, but the data type, instead of as integer, as string, it's simply going to be as node because it's taking a node object. Insert node first checks if the tree is empty. If the tree is empty, stores new node in the array tree at index number nodes. Well, what's the first index? 0. Well, number nodes is set to 0 because we don't have any nodes yet. Increments number nodes, because now we finally have one, stores 0 in the first node. If the tree is not empty, stores a new node in the array tree at the index number nodes. That's the whole point of incrementing number nodes, so we know where it goes next. Accesses the data in the array tree at index first node and compares it to the data in new node. We have to decide, are we going to left or are we going to the right? So when we're saying we're comparing it, we're trying to see, is it greater than or less than? Remember, if it's less than the root node, it needs to go to the left. If it's greater than the root node, it needs to go to the right. It repeatedly follows the pointers until the correct position for a new node is found. We can't override existing data. We got to put it in an open space. Once the position is found, insert node sets the left or the right pointer of its parent node, increments number nodes, write program code for insert node. There is a lot going on here, but nothing that we can't handle. So let's swing over to VB. Let's follow the set of directions and translate it to code. So this method is part of our tree class. So I'm going to do public sub, and then they wanted to call it insert node. Now, don't be intimidated by passing that new node, because what is the data type? It's of the node data type. So just like that, you're ready to go. Now, we're going to need our current node because we need to know where we currently are. Now, that's an integer. We need to know what direction we're going. Are we going left or right? And we need to find out what direction we went, because if it's to the left of the parent node, we need to make sure we update that pointer. If it's to the right of the parent node, we need to update that pointer. So that's going to be a string, and then we need to know what our parent node is to determine, do we need to go to the left or do we need to go to the right? Now, the first thing we want to do is we want to check to see if the tree is empty, because there's quite a bit of code in here. I'll try to make it as simplistic as possible. So if number nodes equals 0, that means we don't have any nodes. We need to set the first one. Well, what's the first one? That's in our tree at index 0. What are we putting there? Well, if the tree is empty and there's nothing there, that root node, index 0, is going to be our brand new node that we are passing down. Now, where's the first node in our tree found? That's found in index 0. So that's what first node is doing. And remember, we need to increase number of nodes by 1. That will hold the index of where the next one is. Now, there's one other possibility, and that is the tree is not empty. So let's find a place for the parameter new node. And we need to keep going until we find -1. Because once we find -1, we have found an open spot. Because where there's a -1, that means that there's nothing there and we can go ahead and put it there. But we need to decide, are we going to the left or are we going to the right? And the only way to do that is to start from the root node and go to the left or to the right. So we'll need to do that. So let's get ready to do that. So the first thing we need to do is we need to add it to our tree array. Well, where does it go? Well, that's why we have number nodes, which holds the index of the next available spot. What are we putting in there? That new node that we're trying to find a place for. Now, the first thing we need to do is we need to set our current node equal to our first node. We have to start from the root node and find out, do we go to the left or do we go to the right? Now, while our current node is not -1, That means we haven't found a spot for it. So we need to keep going until we get to -1. If it's not -1, then we know there's something there. Now, the first thing I need to do is I need to update that parent node to where we are currently. We're going to take our current node, which is the first node, update the parent node, because I need to keep moving through the tree until I find out where I need to go. So that's why we have that here. Now, we're going to check to see if we need to go to the left or to the right of each node. So I'm going to do if our new node dot get data, because as that get data method is less than our tree, and that is our current node where we currently are. We're trying to see, is it greater than or less than? This is checking if it's less than. Then our new current node is going to be where we currently are in the tree. So we're going to do tree. We're going to get that current node dot get left, because we got to get that left pointer, because then we're going to look, because then we know that's not -1, because we're looking to see if it's -1. If it's not -1, we need to continue looking. If we get the left pointer and we see it's -1, then we know we have found our open spot. And our direction is to the left, because we need to know that later on. Now, there's another possibility. There's another possibility, and that's going to be another else if our new node dot get data is not less than, but if it's greater than what? Our tree, our current node where we are, dot get data. If that is the case, then what we want to do is we need to check the right. So then our current node equals our tree, current node dot get right. We're getting that right pointer because we need to see, is it -1? If not, we need to keep moving. So the direction we're moving is to the right. Now, the reason we need to know left and right is so we can update that parent node. So we're going to do this outside of our loop once we find our spot. So we're going to say we found the place for our new node. So now we update our parent node pointers. So if our direction is equal to the left, so if we were going left, well, we need to update that pointer. So then our tree parent node, where is what we were just checking, we need to update that left pointer. Set left pointer. Set left pointer to what? Because remember, our set methods take a parameter, and that's going to be number of nodes wherever we were. So that's one possibility. The other possibility is we don't go left, we go to the right. And if we go to the right, then that's going to be tree, parent node, and what are we going to be setting? We're going to be setting the right node. What index? Number nodes. And then we're going to end if, and then we're going to update our number nodes by 1. There we go. Perfect. That should do it. That's all we need for that question. Let's move on to the next part of the question, and then we'll be able to add things and traverse to make sure this is working. All right, the method output tree outputs the left pointer, the data in the right pointer for each node that has been inserted into the tree. The outputs are in the order they are saved in the array. If there are no nodes in the array, the procedure outputs no nodes. So let's go ahead and let's write code to output our binary tree that we've built out of objects. Now we're still in that same class, so I'm going to do public sub, and they called it output tree. Doesn't take any parameters here, and this is where those get methods are going to come in handy, getting left, getting right, and getting the data. The first thing we need to do is that tree empty. Well, if I don't have any nodes, then I know number of nodes is equal to 0, and I'm simply going to output there are no nodes. That's all I'm going to do. And then if that's not true and I know there's something there, then I need to traverse through the entire tree array. So I'm going to do for I equals 0 to number nodes bit minus 1, because remember, after we add it, it sets up the next node because that's where it knows where to go next. So that's why we want to do 0 to number nodes minus 1. For example, when I add something for the very first time, this number nodes goes from 0 to 1. So if I just have the root node and only the root node and nothing else, my number nodes is 1. That's the next available index. So there's nothing there. So that's why we have the minus 1. Usually when you start at index 0, you're going to include, you start at index 0. Where do you go to? Most of the time, it's going to be wherever you're going minus 1, because the maximum items I can have is 20, but my max index is going to be 19. So that's why we have that minus 1. So then all I'm going to do is I'm going to output the left pointer, the right pointer, and the data. So my tree I need to get that left pointer. Now I'm going to do this based on how the binary tree would be set up. So you have the left pointer. We're going to put a little bit of space. Then what you would have is the tree data. So I'm going to do tree I dot get data. I'm going to put parentheses after this. VB will handle that for me, but we need to make sure we're doing it correctly. And then we need to output the right pointer. So I simply do tree I dot get right. Put those parentheses there. So that's all I have. And that'll print all in one line. I have my next, I have my endif. And just like that, that'll output the tree. And it's those get methods that make that very easy. So let's take a look at the next part of the question. The main program declares an instance of tree class with the identifier the tree. So what does this mean? This means we're going to create an object. The object name is going to be the tree. What is its data type? It's tree class. So let's swing over to VB and let's code this out. Now it does say the main program, so that means we're going to code this out in submain. All right, so anytime we create an object, we're going to do dim. Dim what? What's the name? The tree as new tree class. So just like that, that is how we create our object, and that is how we pick up a point. Let's take a look at the next part of the question. Before we move on to this next part of the question, let's take a pause for a moment. If you are feeling like this question is difficult, then you are 100% correct. It is extremely, extremely difficult. Not only do you have to be familiar with a binary tree, you have to be familiar with object-oriented programming. There is no way I would expect any student to watch this one time and be an expert at it. Remember, it's not about memorizing code. It's about being able to understand that code. So if you feel like you have to rewind and watch a whole question or a certain part again, by all means, feel free to do so. If you have a question, please post a comment below. These paper 4 exams are tough. Make no doubt about it. But by doing what you're supposed to do, studying, putting in that work, you're definitely going to get a return on that time you're investing. You're going to be able to pass it. So if you think, oh my God, I'm watching this, but I have no idea what's going on, that is okay. Lots of people are probably going to rewind and ask questions, and that's okay. So don't feel defeated if you're like, I need to rewind and watch that again. Not the whole thing, or maybe the whole thing, but certain parts. There's no shame in that. Nobody's going to know but you. I'm not going to know. Nobody else around you is going to know. Just make sure you don't feel too overwhelmed where you get defeated. Start thinking with a growth mindset, not a fixed mindset. Remember, challenges help you grow as a programmer. It's not that we're either good at it or we're not good at it. It's not like that at all. We can get good at this as long as we put in that time. So don't give up and keep pushing through. Let's take a look at the next part of this question. The main program, submain, inserts the following integers into the binary tree in the order given: 10, 11, 5, 1, 27, 15. The main program then calls the method output tree. So we'll be able to actually output it in a few minutes. All these integers are unique, so we're simply going to hard code it out. So let's swing over to VB and put this in submain. So we're going to insert these nodes. So we're going to use the object, the tree. Dot what? What? Well, it has insert node. And what are we inserting? We're inserting a new node. What is that node? The data is going to be 10. So we do this over and over and over again. Just insert node, new node, because remember, node is a class. So that's why we have new node, and it accepts a parameter, which is the data. So we are going to insert node, new node. Now, if you didn't put insert node in the tree class, you're not going to be able to use it. So it does matter where methods go. I'm trying to make sure this is in the order it wants, because when you build a binary tree, order does matter. Because if I put 1 first instead of 10, 1 is my root node, and everything is going to be greater than 1 in this instance. The next number we have is 20. So I'm just going down the list. Insert node, that is new node. The next number is 7, and that last number is 15. So new node 15. All right. So just like that, we picked up a few points. Oh, we got to output the tree. So no, we didn't. So now we're going to do the tree, and we're going to call its method output tree. So now we'll be able to see that it's built correctly, hopefully, and that it all outputs, and it should output. And now it's time to take all that object-oriented programming code we did and to test our program. So let's swing over to the output screen and let's take a look and see what we get. Now our root node is going to be -10. So that's going to be our root node. So everything is going to get compared to 10 at first. 11 is going to go to the right of 10 because it's greater than. That means 10's right pointer should be pointing to index 1. Then 5 gets added. 5 is less than 10. So 10's left pointer should be pointing to index 2. So that's what we're going to be looking for. So let's go ahead, let's run this. And yep, that's what it shows. Perfect. So it's working out. So let's check the rest of these. Now, what about 1? 1 is less than 10 and it's less than 5. So 5's left pointer should be pointing to index 3. Here we have index 0, index 1, index 2, index 3. Then we add 20. 20 is greater than 10 and it's greater than 11. 11's right pointer should be pointing to index 0, 1, 2, 3, 4. So I looked for index 11 or data 11. What is its right pointer? It is indeed pointing to index 4. I add 7. 7 is less than 10 but greater than 5. 5's right pointer should be pointing to index 0, 1, 2, 3, 4, 5. I look for data 5. Its right pointer is indeed pointing to 5. The last one I have is 15. 15 is greater than 10, greater than 11. So if I look at 15, well, 11 is pointing to 20. So 15 is less than 20 because 20 is already taken up a spot. So 15 is less than 20, which means 20's left pointer should be pointing to which index? Well, index 0, 1, 2, 3, 4, 5, 6. Here I have the value of 20. What is its left pointer pointing to? It's pointing to index 6. Everything that doesn't have something to the left or right of it, like 11, doesn't have anything to the left of it. So it has a null pointer, which is represented by -1. 1 doesn't have anything to the left or right. It also has pointers of -1. 20 has nothing to the right of it. It shows -1. Neither does 7 and 15 on the left or the right. That's -1. So that question was tough, but it's good because we can always continue to sharpen those skills. But let's take a look at question number 3, the last question on this paper 4 exam walkthrough. A program sorts an array of integers and searches the array for a particular value. The array of integers, number array, stores the following data in the order given. So they give us some numbers here. The array is declared and initialized local to the main program. So not a global array here, but an actual local array. And all that means is instead of declaring it outside of submain, we declare it inside of submain. So let's swing over to VB and let's get these numbers programmed into that array. So we're simply going to dim number array. Now, if you want, what you can do is you can load them all at one time. So you can do as integer, don't put a number in here. Then what you can do is you can open a set of curly braces and put all the numbers in here if you want to. So this is just an alternative. Usually I do not do this at all, but you can go ahead and do it this way. I'm just trying to show you something different. Just put commas in. You can do this with strings. You can do this with anything you want. What you need to know is if you do this, it is not possible to omit index 0. Well, I guess you could omit index 0 if you put a place value in, but we're not going to do that. But whatever you put first is in index 0. So here, my max index is actually going to be 6. Index 0, 1, 2, 3, 4, 5, 6. But that is how you do it, or you can type it out 7 different times on the line if you want to do it that way. But both ways will serve the same purpose. So let's take a look at the next part of the question. I couldn't get this to fit onto the PowerPoint slide, so let's go through it so we know what we're doing. Here, we have some variables declared. We can do that, no problem. So we have a function that does a recursive insertion sort. It accepts the integer array as an array, the number of elements, which is going to be an integer, and it's going to return a sorted array. If number of elements is less than or equal to 1, then we know they've all been sorted, so we return the integer array. If not, we're going to have the recursive insertion method call itself again. We're going to pass that integer array again, and then the number of elements we're going to decrease by 1. The last item we're going to we're going to set the integer array number elements minus 1. Then check item we're going to set to number elements minus 2. And if then it's going to loop again. We set that to true. Now, if check item is less than 0, then well, there's nothing left to check, so loop again is going to be false. If the integer array check item is less than the last item, what we're doing here is we're actually doing the sorting here. So then we create another while loop again. Integer array check item plus 1. What are we putting in there? We're putting in the previous item that we checked. This is where we're getting them to actually swap places. And then we check to see if it's less than last item, then loop again is equal to false. And what they want us to do here is write program code for the pseudocode function recursive insertion. I'm not going to be able to display this and my VB code at the same time. So we're going to break it down into sections so it's a lot easier to go through and check to see how I converted it into actual VB code. All right, so what we're going to do is we're going to do function recursive insertion. Let me make sure I spell it right. So we're doing an insertion sort by ref, and they used integer array. So I put the parentheses to show I'm accepting an integer, and then the data type as integer. Then the other thing they have is number elements as integer. And what is this going to return? This is going to return an integer array that has been sorted. So we have by ref integer array. We don't want to make just a copy of this. We actually want to access it and sort it. That's why we're using by ref. Number of elements we're not going to change at all. And then this part right here as integer shows that I'm going to be returning an integer array. So we're going to need those variables. Last item as integer. We also have check item as integer. And then we had loop again as a Boolean value. So all we're doing is simply taking that pseudocode and we're turning it into actual code. So let's go ahead and let's handle that first block of if statements. So we're going to break it into the blocks of if statements. We got 2 of them followed by our actual loop. So by breaking it down, it'll be a lot easier to manage. So starting with the first one, if number elements, and all we're doing is taking their pseudocode and converting it to actual code. If number of elements elements is less than or equal to 1, then what we're going to do is we're going to return the integer array, which is our parameter. And that's going to work because I have my set of parentheses over here. That shows that we're returning an array. Now, if it's not less than or equal to 1, there's only one other thing, and that's what we need to handle that. So that is a recursive insertion. And what are we passing? Well, we're passing the integer array, and we need to pass it as it keeps getting sorted. The number of elements, well, I just sorted one, so I'm not going to sort all of them again. So that's why we have -1. What was the last item we just did? Well, that's going to be in my integer array, and that's going to be number of elements -1. That was my last item. And then the item I'm checking it against, that is number of elements -2. So having a basic understanding of an insertion sort is crucial to this. Let's put some more space. Scroll down here a little bit so we can see. Let's go ahead and code out the second if block. Now in our second if block, they set loop again equal to false, which means we need to set loop again equal to true right here. Because remember, we're going to be looping while loop again equals true. This if block could change it to false. So if check item is less than 0, then what we're going to do is we're going to set loop again equal to false. So we need to make sure we set it to true, otherwise it will already be false. Else if the integer array check item, checking that index that we're currently at, we need to see if it's less than or equal to the last item that we just checked. If so, then loop again. We don't need to loop again. So then right here, right after that if block, we're going to start our while loop. So we're going to do while loop again equals true. And then we're going to code out this while loop. We can go ahead and start it, and then we'll do the if blocks inside. So we're going to do the integer array, check item, the next one, +1. We can want to compare it to the previous one, which is integer array, check item. And then once we do that, we update our check item, we decrement it by 1. Now we can start those if blocks. So we're just going to do if check item, which we just decremented. If it's less than 0, then we're not going to loop again. So we're going to set loop again equal to false. Now there's another possibility, and that's if the integer array, the item we're checking, is less than or equal to the last item, then we need to code that out. And that is loop again is also set to false. We have our end if. Let's make sure we have our end while. There we go. And there's one more thing we need to do after the end their loop, and that is integer array, check item +1. What are we putting there? We're putting the last item, and then we're returning that integer array. So just like that, we have it. Let's take a look at the next part of the question. We're going to amend the main program, so submain, to call recursive insertion with the initialized array, number array, and the number of elements as parameters. Output the word recursive, output the content of the returned array. So let's program submain so we can do that. All right, so the first thing we're going to need to do is we're going to need number array sorted. And that is going to be 6 as integer because we've got to call this recursive insertion. So number array sorted equals recursive insertion. We want to pass down the number array. Now when you're passing the array, you don't need to put in any parentheses, and then the number of elements. How many do we have? We have 7. We have 1, 2, 3, 4, 5, 6, 7. All we have to do, so it's going to run its recursive insertion sort. It's going to store it into number array sorted. All we need to do then is simply output it. For I equals 0 to 6, because remember, I'm starting at index 0 here, and there are 7 items when I count 0 to 6. And all I'm going to do, what am I outputting? That number array sorted index I. So let's save it. Let's run this thing, and we should see those numbers sorted. And they are sorted. There are 1, 2, 3, 4, 5, 6, 7 items. Here we have 1, 2, 3, 4, 5, 6, 7 items, and they are in order. Let's take a look at the next part of the question. All right, the next part was to test our program and take a screenshot of the output, which we tested it to show that it does work. The function recursive insertion can be changed to use iteration instead of recursion. So that means a method that doesn't call itself using a loop. Write program code for the function iterative insertion to perform the same process as recursive insertion, but using iteration instead of recursion. What does that mean? That means write a standard insertion sort that is not recursively. So let's swing over to VB. Let's code out an insertion sort for the set of test data that they gave us. Okay, so I have my function, iterative insertion. I have by ref integer array. Definitely want to put those parentheses to let them know you're passing an array, the number of elements, and then returning the array. Now, they want it to be just like the recursive one, except for they want it done non-recursively. So we're going to need a couple while loops here. I'm going to make the same variables they had to show them that we can do it just like the last one. So I'm going to create those variables because I'm going to need them all. And then all I'm going to do is I'm going to have a nested while loop here. So while, when does this need to loop? While the number of elements is greater than 0. If my number of elements is greater than 0, then I know I still have things that I need to sort. So I need to load those items up. So my last one is going to be my integer array, and that's going to be the same thing as my other one. Number elements minus 1. So nothing too difficult there. So integer array, not really sure what happened there. And then our check item, because we got to compare these, our check item is going to be the index, that is going to be number of elements minus 2. If you have no idea how an insertion sort works, I strongly recommend that you stop here, learn an insertion sort so this makes sense to you. It's very important that it does. Now, right here, we're going to do loop again, just like we did, and we're going to say loop again equals true. We want to do that before we check our if statement. So we're going to do if check item is less than 0. Then what we need to do is we need to say we're not looping again. So we simply set it equal to false. Then we're going to start. Actually, that's not the only thing we need. Hold on. Else if, because that's one possibility. The other is that the integer array check item is less than or equal to the last item. Then we also need to set loop again equal to false. There we go. Now we're all set. Then inside this while loop, I'm going to have another while loop. You got to have a nested one. So while loop again equals true. And you'll see this red line. It'll go away in just a minute because you need to in while for each of these. So while we're looping again, we're going to take that integer array. We're going to take the index of check item plus 1, which is the next one over. What are we putting there? And you'll see this is very similar to the other one that we had. Check item. Then we're going to decrement check item. So very, very similar. Then we check if the item is less than 0. If so, we're going to do the same thing we did. Loop again equals false. And then, of course, we're going to check that other possibility. Else if the integer array of check item is less than or equal to that last item, then we're not looping again either. So loop again equals false. So it's hard to talk and code at the same time. Sometimes when you're saying like item, you're typing out that item. And then let's see here. I think that is all we need for that inner loop. Let's check here. Yep, that looks good. Now make sure you're outside this inner loop, because when you're outside the inner loop, this is where the switch is going to take place. So you're going to take that integer array. You're going to take the check item plus 1. And what are we putting there? Well, that's going to be the last item, and that's only if we need to flip-flop them around. And then number of elements, we are going to decrement by 1. Then all we need to do is we need to return that integer array. And that is how we're going to write a standard iterative insertion sort. It's not too tricky once you know what you're doing. You need to have a firm understanding of it, and it'll make this code make a lot more sense. But basically what we're doing is we're starting from the end and moving our way to the right, and we're taking an unsorted part of the array and comparing it only to the unsorted part. So we're splitting the array really into two parts. One part that's sorted, and then what we're doing is we're continuing with the part that is unsorted. An insertion sort works just like a deck of cards. So let's take a look at the next part of this question, which I'm sure is going to have us output it to make sure it's working. So we're going to call iterative insertion with the original initialized array, number array. So we're going to pass that down as a parameter. Output the word iterative, and that's so they can see it different from recursive. Output the content of the returned array. Once we do that, we would take a screenshot. We would paste that into our evidence document to pick up points. So let's swing over to VB, and let's call this iterative insertion sort. So we're going to need another array. So I'm going to do number array I sorted for insertion sorted as an integer. That way they can still see the other one. I guess I could use the same one, but I don't want to do that. That way if there's something not working, it's easily, I know what it's for. So number array I sorted equals, and then we're going to call that iterative insertion sort. We're going to pass down number array, and there are 7 elements that we are working with here. Then we're going to do console.writeLine, and we're going to say, what did they say? Oh, iteration is what they wanted us to do. And then we're going to do for I equals 0 to 6. We're going to do console.writeLine, and all I'm going to do is output that number array I sorted for insertion sorted, an insertion sort, and then I. And I don't think I put recursive up here earlier. I did not. So here we're going to do a console.writeLine. We're going to do recursive. All right, so now we got to test it. We got to run it, and we should see that it's sorted 1, 8, 15, 22, 85, 164. So we can see the recursive and the iterative, or using iteration, that it works. So very easy to do there once you have a firm understanding of recursion and an insertion sort. You need to know all of those. Bubble sort as well, because that could appear on the exam. All right, let's take a look at the next part of the question. I feel like we're getting close to the end of wrapping it up, so let's take a look at the next part. The recursive function binary search takes the parameters. I love recursive binary searches. I enjoy them immensely. I like them a lot because they're very, very efficient, and they're not extremely difficult to code out. So if you're not familiar with the binary search, you can learn it right now recursively. Insertion sorts, not so much, but a binary search, which is not a sort, is pretty easy to work out. So we have takes the parameters, the integer array, an array of integers, first, which is the index of the first array element. So I'm actually going to use lower bound, my LB, for that. Last is the index of the last array element. That's the upper bound. And then the search item, which they're using the word to find, an integer to search for in the array. I have to use these parameters, but if I know what I use when I write them, it makes using these a lot easier. The function uses recursion to perform a binary search to find an integer array. The function returns the index where to find is stored, or returns -1 if to find is not in the array. Write program code for the recursive function binary search. Let's swing over to VB.net and do that right now. So when you're setting up a recursive binary search, you're going to pass that integer array repeatedly. You're going to pass first which is the lower bound, last, which is the upper bound, but you're going to be adjusting these because if the item you're looking for isn't in the middle of the array where you're currently searching, you need to, if it's greater than or less than, you need to update first or last accordingly, and then to find, you need to pass that again, and of course we're returning an integer. So we're going to dimensionalize mid as integer. The first thing we're going to do is we're going to see if first is greater than last, because if my lower bound is greater than my upper bound, it hasn't been found. I'm simply going to return -1 to let the user know, hey, it is not there. Now, if the integer array, one possibility is where I'm looking, is equal to find. I found what I'm looking for. If I found what I'm looking for, I'm going to return mid. Now, there's another possibility of where I'm currently looking in the array that it's actually greater than to find. If it's greater than, then I need to call my binary search. So I'm going to return binary search. Now, Cambridge didn't need to, the way their recursive statement was worked out earlier. If you actually use the keyword return, it will not work. When you're using recursion, it's based on how the stack unwinds and when the return statement is actually called. You can't just put return to return because they wrote it earlier. We used their code because remember, we converted their pseudocode to actual code. So because they didn't have the return or call statement or the return statement, we didn't either. And we don't use the keyword call in VB. So anyway, we return the binary search and then we pass those parameters. So I'm going to pass the integer array again. I'm going to pass my first. Now, last, I'm actually going to update, and that's going to be mid -1, and I'm going to pass to find again, else if. And now the other possibility is the integer array mid is actually less than to find. If so, I need to adjust my first. So I'm going to return my binary search. I'm going to pass that integer array, but first is going to be mid +1. Because if I look at index 0, and I know that the item is in index 0 is less than the item I'm looking for, I don't need to check index 0 again. So I need to increase my lower bound from 0 to 1. If I look in index 4 and the item in index 4 is lower than what I'm searching to find, I don't need to search index 4 again. I need to search index 5 plus whatever my upper bound is, divide by 2, which I forgot to do. So we'll need to go back and do that. Not a problem. Last to find, and then that will return the index when this statement becomes true. If this statement never becomes true, this will return, this will return -1, showing that it didn't work. To calculate mid, you're going to do mid equals first, in this case, first, which is your lower bound, plus last, integer division divided by 2. Make sure you do not use this division sign. You want to use integer division divided by 2. That is how you do a recursive binary search. It is that short. You have mid. You check to see if first is greater than last. If so, then we know it's not in there. Then we account for all three possibilities. We found it. If it's greater than what we're looking for, if we're in the array and the item is greater than what we're looking for, we don't need to check anything beyond whatever our upper bound is. We need to actually decrease it so we're not checking it again. If it's less than what we're looking for, well, we know it's not further to the left, so we need to update our first value or our lower bound by doing mid +1. All right, let's take a look at the next part of the question and get ready to wrap this paper up. All right, last part, write program code to amend the main program. So submain, call binary search with the sorted array and the integer 644 as our to find value. Output not found if 644 is not found in the array. In other words, if it's -1, output not found. Output the index if 644 is found in the array. Test our program, take a screenshot. So let's swing over to vb.net and write this last section of code to wrap up this paper 4 walkthrough. All right, so we need one more variable. We'll do index as integer because we need to find it. So then what we're going to do is we're going to set index equal to, we're going to call our binary search. We're going to pass down one of the sorted arrays. When you're doing a binary search, the data must be sorted because you're checking to see if it's greater than or less than the item you're looking for is greater than or less than the item you're at. Binary searches will not work if the data is not sorted. So I'll use number array sorted. So I want to pass that down. I want to pass down my first, which is going to be 0. My last item is 6. The target data we're looking for to find will be 644. Then if index is -1, then we're going to output item not found. Item was not in the array. And then we can use an else statement because if it's not -1, that means we found it. And we're going to output that. But we're not just going to say we found it. We're going to say we found the item at index, and then we're going to output the index. There's only one thing left to do. That is save, run our program, and we should see 644. We found that at item 6, which is true because 644 is the last item in our index once it has been sorted, and we know our max index is 6. The first item we should find is 1. So let's change the 644 to a 1. Let's run our code. And when we run our code this time, we should see that it shows index 0, and we do. So it is working. We're going to change this back to 644. So when we take a picture of it and paste it to our evidence document, we can see that it does indeed work as it's supposed to. Hope you guys found this full paper 4 walkthrough helpful. If you did, please take a moment and give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.